G'day guys, it's Calvin from the Cartoon Company down under in New Zealand. I've just been wiring this setup onto the engine, and I've done another video on it, but I got to the starting point and I did this. Now that was because it wasn't in neutral or park. Easy to solve. So I plugged this thing in and I turned it to park. Good. And I went over here again and I went like this. Can you hear that? It cranks over really, really fast because I've got a 2 kilowatt starter motor in there. It's awesome, eh? Cranks over really well. However, it is actually meant to run. Just been wiring it, checking it, running through it. So I thought, what a perfect opportunity to do a little bit of diagnosis work. Well, it wasn't, because I'd rather it just ran. But I find it's better to actually have a real situation, as long as I'm quite calm, which I'm generally pretty calm, to work out what's going on. I've already gone through a bit of diagnosis, but let's get in and have a look at it, have a check, see what we find. Yeah, let's do that. Just lost myself for a moment there. Okay, so I've got an ECU. First thing I do, and I've got multiple tools here. I've got this little scope. I like that little unit. I've got my multimeters. Good. This one's getting a bit old. I've also got these units. Well, I've got this one, SXE probe, sexy probe. We've got this one, Digitech multifunction auto tester. And we've got this one, my power scope. Now these are fantastic, but also can blow a lot of shit up if you don't know what you're doing with them. Watch. It allows you to put an earth. If I swap this over to an earth, so my test lead is going to an earth. It allows you to fire 12 volts out. Same as this one. So someone who doesn't know what they're doing or doesn't engage the brain can cause some serious damage with those tools. They're fantastic tools. Don't get me wrong, but if you don't know what you're doing and you're not prepared to read the instructions and understand, then you have got the potential to blow shit up. Don't come crying to me if you get one and you blow it up, because I'm just going to offer you some tissues. So let's check some voltage to the ECU first. Which tool should we use? So my go-to in this situation is a plain old test light. And all I'm going to check, I'm going to go here like this, plus B. Yes, it's got voltage. Ignition off, ignition on, plus B has got voltage. You can also check BAT, an ignition switch, but if we cheat and go straight to plus B, yes, we got voltage. I then go up, and coils and injectors on these engines are linked. So really simple. I'll go on the back of here. Can't get into the back of the injector plug. Pop an injector off. I have voltage. I can do the same at the coils or igniters. Hey. Here we go. Voltage there, coil, voltage there, And we can check the plus B circuit on the engine, but in this one it's all linked anyway, and it should be this one here. And I can do the same. Let's use this one. 12.5. 12.5. Look at that. The ECU has voltage. That's a good start. Next step. Does the fuel pump go? Really easy to check. This one isn't running fuel pump control from the ECU. It's got an external box. And that will tell me a couple of things. It has to get an igniter or a tacho signal to run on this one. So that'll tell me some information. Let's have a look. So this little box, tachometric relay, we pop onto the fuel pump circuit, we crank it. And look at that. And you'll notice it's on for a little bit, and then it turns off. That's interesting. So I didn't notice that the very first time that it turned off. I just went, has it got it? Click, bang. It didn't hold it for a bit longer. So it's turning on, it's getting a tacho signal for a little bit, then it's stopping. Tacho signal comes from the igniters. Right, let's check cam and crank sensors. They're important. Oh, wait. Now this engine, so Old Yeller has been raided for parts a few times. This time it lost injectors. They were needed for a job, so they came out because I knew they ran. And that job's now going, but I just banged some second-hand injectors in Old Yeller, so I wasn't sure they were any good. Some brake clean, engine start. It still didn't want to go. And I did check the dampener screw had popped up. So even though the fuel pump was only coming on for a second, the screw was up. Next step, let's check some spark. So I'm only going to check the one side, which is a little bit naughty. And she goes. Have a look up in here. My next go-to is the cam and crank angle sensors. Needs those for our injectors and to make spark. So let's check that. And I've had this loom apart. I've changed plugs. Maybe I've stuffed up. Yeah, it happens. More than I actually show on camera, but that's beside the point. Okay, so I've had that plug apart. I double checked it against another loom. I have spare looms and it checks out okay. So let's multimeter continuity test down to those crank sensors and to the cam sensors really quickly. So what tool am I going to use to this? No good. I'm going to use this multimeter. So I put it on continuity, check it. Perfect. I'm going to start off and checking all the earths to these circuits. These are NE negative, G1 and G2 negative. So G1 negative, G2 negative. They all have continuity. They lead up to this plug, switch looms, and then come down to each sensor. It is an advantage being able to pop the sensor off. And we're going to go into the black wire on the crank angle sensor, onto there, And we're going to go into NE positive on the ECU. We have continuity, so that's good there. Over to the negative. And that's got an earth with all the, got continuity with all the earths. And onto there. Next cam sensor. We go into the red wire. And this will be, we're on the left hand side, relates to number 1 cylinder. So it's cam angle sensor number 1. It says G1. The annoying beep shows it's got continuity. And the earth. It's all good. The left hand cam sensor is G2. You'll have to trust me that that's correct and working, because it is. So I've got no spark. I've got continuity to the sensors. What I'm going to do now is see if the sensors are actually working. And you can check the resistance of the sensors. Let's do that, shall we? So right there I've got about 1150 ohms. That's at the sensor. My auto function one doesn't always pick up nicely. You have to put it on manual. And I actually wonder if I can do the same test here. Here I am at the ECU, 1150. And the next one, this is number 1 cam sensor. And this is number 2 cam sensor. So you can see I can actually shortcut this process by testing it at the ECU. Still get the resistances that we need. That's pretty good. Next, I'm going to see if they're actually producing a pattern. See if they're making a little bit of a squiggle on one of these devices. So for this test, we're going to plug it in. Now I've got the proper little probe, back probe things. They're shit. I've got my split pin poked into NE, much better. And I would use this one on AC voltage, but it may have had a little bit of an incident in the past and the top half doesn't actually work. It's still my favorite though. So we're going to go to this one. So this is just a plain, ordinary, everyday multimeter. I've got it on volts. It's actually picking up some voltage out of me. I'm earthing one side. I'm onto here. Oh, I use my jump cable for something else. Put this where we can see it. I'm onto NE. You could see the multimeter was jumping around, so I've switched it to straight AC voltage, because these sensors put out AC. So I've got 0.7. And it went up to 0.4 AC volts. Perfect. That is working. We'll do a cam sensor. Hopefully I've got that in there. So again, very little. And you see it is producing an AC voltage. The reason the cam sensor is a lot lower or more inconsistent, less consistent, is it's got one tooth every 2 revolutions, whereas the crankshaft position sensor's got 12 per revolution. So for every 2 it's got 24 compared to that cam that's only got 1 in that 720 degrees of engine revolution. So a different voltage. But we can see we're getting voltages. That's all it needs. This ECU needs a crank and a cam input to generate spark, to generate a signal out to the igniters. Okay, that's all it needs. This engine should go if that ECU is good. Before I plug in another one, let's have a look at some of these other devices of what I test with and what I get. Okay, I'm back on the crankshaft position sensor. I'm getting rid of that one, and we'll get this little power scope, popping it on here. We're looking at the screen. It's certainly doing something. Let's get a close-up of that screen. Hey, connect back on. I need more hands. That ceiling light's just in the... there we go. Let's have a crank. So as you can see, the power scope is showing that the signal's moving. And that's probably good enough to say, yes, it is working. The Digitech, didn't give me any results that I liked. But this one, and this isn't a scope analysis, is great for just checking some voltages. Yep. And earths. But for checking that one, didn't really do the job. My sexy probe. Now this is actually one of my favoritist tools. It's got some LEDs on it, so it works like an LED test light. You can see it's had a beating because I've used it lots. However, in this situation, it sucks. I pop it on here. Here we go. Hopefully we can see some LEDs. I give it a crank. However, if I change it to a frequency, try it again. So as a reference point, if I had an engine that wasn't running and I chucked this on, put it on frequency, got a 10% frequency, I'd say that's working. But not the best way. So gravity will catch that one. I'm really lucky it's got one of those stretchy leads on it because it stopped it from smashing in the ground. So the best tools so far have been a simple multimeter or that power scope. My next one I actually prefer the most though in this situation is my little scope. So this is just a really, really basic cheap scope. Really basic scope. I actually need to connect some lines, some wires. I'm in an earth. And take this. I'm going to connect it permanently. I'm going to sit it there nice. I'm going to sit that around my split pin nicely. Yep, we're good. And we're going to give it a crank. And look at that picture. So I can clearly see the pulses coming up, down. I can see each individual picture. That is my preferred way, so I can actually see they're all even, they're not bent. I've got it on 0.5, so we might just change that a little bit. Put it up to 2 volts, and we'll do that again. So they're on 2 volts. It's looking really good. Now this is a 2 volt, so I'm getting just under 2 volts. It's pretty good. I'm pretty happy with that. So my little scope is my favorite tool for doing this job. I love the Sexy Probe. The Sexy Probe is great. I use it a lot on a lot of jobs. However, if I want to look at a proper scope pattern or a proper picture, this little scope is great. And, well, when I got it, it was actually a lot of money. But nowadays, this sort of stuff's cheap. Now, you might ask why we've got a little bit of difference in the test techniques and the voltages. As in, the multimeter was about 1/2 volt. They've all got a little bit different in their voltages. That's just the way they can read them. Sometimes they'll average out the voltage up and down. Sometimes I'll actually read a peak, like the power probe. I might just run that power probe again because it's also got a frequency on it. We'll see what comes up. So the power scope has actually got a max voltage, just under 2. It's got a frequency and a duty. And a little picture. And that was these things were only like $125. So that again, really cool. I wonder what that button does. This one, as a home handyman tool, can be really helpful to use. So even though I've put all these tools on, showing you a little bit more, it still doesn't run. But we've checked the basics. The engine has got voltage to coils, injectors, to the diagnostic box, which is the oxygen sensors and purge and stuff like that. The ECU has got voltage. It has fuel going to the rail. The dampener's popping up. And as I said earlier, this ECU needs crank angle to make spark. Crank and cams, it will make spark. Only needs 1 cam sensor. It'll make spark. It'll generate it. So that ECU must be goosed. I actually pulled this one apart and checked it inside while I was wiring it, and it looks clean and tidy. No signs of damage visually. It almost looks like someone serviced it. The lid came off easy as well, but it does not go. Let's bang another one up and see if this engine runs. In with this one. Now this one, I deem it to be stuffed. I've written on it that it's stuffed. I've looked inside and there's noticeably leaking capacitors in there. So there is a chance when it goes away to be repaired that it might not come back to life, though it may. Okay, so we've got it like this. We've got test tools everywhere, not testicles, test tools, guys. And we'll see if it's got some spark. Well, it seems that it does have spark because it runs. There we have it. ECU, diagnosed, it's buggered. Flick another one in. that I now know is a runner, but does need to be repaired, and voila, it goes, starts, runs. I'm happy. I need to tell the customer that his ECU's buggered, which isn't the nicest phone call to make, but at least I know 100% that that's what the problem is. There's no guessing. I physically checked it, and we can see it didn't run, and now it does run. So this diagnosis stuff is really easy if you've got some of the right tools, and there's a number of tools that will do the job. I'm going to do a few more videos using the power probe, because it also has a KV tester for checking misfiring spark plug leads. But that's enough for now. I'm back to finish the wiring video of this job, and we'll talk to you again soon. Catch you later.